So that's that question. So, in a certain binary star system, two stars with identical mass m have equal and opposite velocities v2 on the opposite side of the same circular orbit with radius r. In another system with three identical stars of mass m, as before, it is observed that all three stars are equally spaced around with the same radius r as before. What is the speed v3 of these stars in terms of v2? So, to draw it out, we know that in the first case, we have m here, we have f2 there, f2 there, this is going at v2, v2, and then that's r. So, solving this, we know that f2 equals m v2 squared over r from circular motion, but this is equal to the gravitational force between them, which is over 2r squared. So this is m v2 over r equals g m squared over 4r squared. So from this, we know that v2 equals gm over r, I believe. No, 4r. So, that's from the first one. Now, for the more complicated one, I'm going to draw a bigger circle here. We have them here, here, and here. So we have m, v3, and m, v3, m, v3. And then we have the centre here with radius r. And then here we actually have a force we're going to call F3. But the actual force is going to be like here and there. So now what we've got to do is we've got to work out what this angle is. So this is just going to be 360 over 3, which is 120, which leads to this being 30, and this being 30. Which leads, if we resolve, what we're going to do is we're going to resolve this force here, this way, 60. So we know this is F cosine 60, and this is F sine 60. So, from this, we can work out that F3 equals m v3 squared over r, and this equals 2 F sine 60. Okay, because this is the only force that's going on it, and it's similarly going on it like this way as well. So, now, like putting this in better terms, we have this equals m v3 squared over r equals 2 root 3 over 2 sine 60 plus f, and the f is actually gm squared over 2r cos 30 squared. So 2r cos 30 because it's just the distance between those two objects. Okay, so yeah. Now, simplifying this, we have v3 equals v3 squared equals, cancelling out some of these things, we have, I believe, gm over root 3 is going to be there, and 2 and 2 cancel, over 3r, I think. So, now making this smaller, we can now look at the value. Oh, and up here this is v2 squared. So, v3 squared over v2 squared equals root 3 gm over 3r multiplied by the negative reciprocal of the other, which I'm just going to say is 4r over gm. So we can see that this cancels this, that cancels with that. So this equals 4 root 3 over 3. So now, square rooting, we have v3 equals a square root of 4 root 3 over 3.